There are two quadratic functions which have two x-intercepts, -1 and 5, and their x-axis is symmetrical. Solve for two quadratic functions if the distance between the vertices are 18. We solved this question before, but now we're thinking about a better way and more efficient way that we can approach this question faster. So at first, before we solve first question, let's think about the two types of our quadratic function. And we need to remember that both of our types are defined by our leading coefficient. And our leading coefficient will going to be notated as A. So the first case of our quadratic functions graph type will going to be the case where the A value is greater than 0. Which means when our leading coefficient is positive value, our graph of our quadratic function will open, or we can say it goes upward. When the quadratic function's graph goes upward, for example, it will look something like this, that keeps going toward upward and never intersects at specific one point. It will going to contain one specific point right over here, which is one of the most important things in our quadratic function. We call it as a minimum point over the lowest point of our quadratic function. And these are defined when our A value leading coefficient is positive value. Now let's think about the second case. Our second case will going to be the case where the A value, our leading coefficient, is less than 0. Which means when our leading coefficient is negative value, our graph of our quadratic function will open or we go downward. When the quadratic function's graph goes downward, for example, it will look something like this, that keeps going toward downward and never intersects at specific one point, but then you're going to contain one most important point in our quadratic function, which we call it as the maximum point or the highest point. The highest point on our quadratic function. And this is going to be defined when our A value is less than 0. And now let's think about what our definition of the vertex will going to be. Our definition of a vertex generally, our vertex is same thing with the adding the number of possibilities between the minimum point. So it is the same thing with adding the number of possibilities of the minimum point and the maximum point. If you add those two number of possibilities, it will create our vertex. This is what our vertex definition will going to be. And now let's think about what will going to be the x-intercepts. So let's think about what will going to be the x-intercepts. And after this, we're going to talk about what the y-intercept will going to be either. So first of all, as we have learned in a lot of videos, x-intercepts, we also call it as solutions in our quadratic functions. This will going to be a case where if we convert this into a coordinate, it will going to be 0. So it's going to be x, 0. Which means we know that x value should always be our input. The input where we input specific values to our quadratic functions. And for our y value will going to be specific output of our function. And these are the two most important things when it comes to solving the quadratic function. So when the x value is equal to something, when it exists, our y value, our output of our function should always be equal to 0. This is what our x-intercept will going to be. Now let's think about what our second case, y-intercept, will going to be. Our y-intercept is the same kind of concept with our x-intercept. It will going to be the case where our x value is equal to 0, our y value exists, which means when our input of a specific function is equal to 0, our specific output of the function output of the function which we notated as y exists. So these are things that we need to know before we solve for these questions. Now let's think about the most important thing when it comes to solving this. Let's think about what the function is. So from here, let's think about what the function is. The function is, in a short way, it will going to be the extensions or the expression between the x and the y. So we can see that between the input, so it is a expressions between the input and the specific output of the function. Now let's think about what our quadratic functions will going to be. Our quadratic function, quadratic means it is a second degree power, which means instead of x in the first power degrees, it is the x second degrees power and the y's expressions. And if you think about just a general term what our function is, from here we can know one thing. Function, so our function, it can be either linear, quadratic function. Function is a thing that always requires a specific input. And for that input, we kind of notate this as the x in our coordinates. But if we input some specific values into our x values in our specific equation, it will obviously gonna generate a specific output of our function. But for that output of our function, we usually notate it as f of x or y. The reason why it is f of x is because we can also relate right over here. We know that input is x. For the function, we write it as f because from the front word. And then if we input x value into our f, it gives us output f and the x, which we call it as f of x. These are things that we need to know when it comes to solving this question. And they said it has two x-intercepts, which means when the x value exists, y value equal to 0. Whenever y value is equal to 0, there are two x-intercepts, -1 and 5. But then they said in their information, they said these two functions are symmetrical, which means if you flip this, they are going to be congruent. This is what our symmetrical means. But then they gave us that is the x-axis symmetrical, which means the two functions are congruent according to our x-intercepts, which means if you say these two functions are congruent, for example, if they're congruent, it will look something like this. And these are just example of our function, but then they're congruent through the x-intercepts, which means there is our y-intercepts and there is our x-intercepts. The standard of dividing these two functions into two will going to be our x-axis. So we can imagine how the two functions will look like on our coordinate plane. This will going to be 2x, so 2x axis symmetrical. So 2x axis symmetrical functions. So two symmetrical functions. And then we can know one thing here. Our vertex, if you review what the vertex is, it is a number possibility addition between our maximum or the minimum point, depends on the size of our a leading coefficient. And for our vertex of our function, they gave us one more clue that they are 18 far away. Now, when it comes to solving this question, which I'm gonna start from now on, this will going to make the whole difference between the first case and our second case, And obviously this this method will going to be way much faster than the first one. The last video, so this was the first way of solving this problem. In the last video was converting our forms into a vertex form. And even though we don't have to use vertex form now, let's review what our vertex form looked like. Our vertex form was y, which we're going to be output, is equal to a times x minus p squared plus q, where if you think about each variables, what each variable does, a value will going to be our leading, so a value will going to be the leading coefficient, and if you think about what our leading coefficient will going to be, our coefficient is the integer beside variable. And if you think about what our leading is, leading will going to be the highest power or a highest degree terms for the variables. So in this case, we can know one thing. Our a value is the leading coefficient, which is highest degree variables integer. That means our highest degree variables were going to be the x squared, since we knew that quadratic functions largest degree power term is square x squared. So leading will going to be x squared, and the coefficient will going to be just a number beside x squared. And now, if you think about what this integer, our a value, does, it is exactly the same thing with the others. This defines, the a value defines what we're going to be defines. It will define the types. So it will going to define the types of graph and the vertex. This is what our a value will going to do. Now if you think about what our p and the q is, we know that every single coordinates, if you don't know what our coordinate is, we can review it right now. Coordinate will going to be point. It is the point on our graph. That is what our coordinate will look like. And usually when you convert it into a coordinate, it will going to look like x comma y. But then our vertexes coordinate will turn into p comma q, where the p is our x value, our input, q value is our y value, our output of our function. This is what our vertex form is. And the reason why we convert this into a vertex form is because it was convenient when it comes to solving for the vertex of a function. But I know one more convenient way, and I'm starting right now. So that is it. Terms, we are not using the 18, we're only using the x-intercepts. And as we think about what the x-intercept is, we kind of review it here. We're going to be when the y value is equal to 0, our output is equal to 0, input of the function should always turn into some number. But then, right over here, we can, our x-intercept was -1 and 5. From here, we can convert this into a binomial form. Now, if you think about what our binomial form is, it is a form that is optimized when it comes to solving for our x-intercepts. Vertex form is optimized when it comes to solving for our vertex. Binomial form is optimized when it comes to solving the x-intercepts. So we can prove it here. There should always be two cases. And they said it is the x-axis symmetrical, which means one of them should go upward, another one should go downward, which means one of their a values should be positive, another one a value should be negative. Now let's use the different color to do this. And so that is a binomial, which means there will obviously going to be a two nomials. But then let's think about our x values. So we're going to be x. There are obviously going to be two x's, as we'll learn in a lot of videos, which if we multiply, it gives us x squared. But then all you have to do is we need to write plus 1, negative 5, plus 1, negative 5. We simply do it. The reason is because our x values, the x values from here, already think that if we input specific values, which will going to make our whole expression turn to 0. From here, our x value should be negative 1, which is right over here, in order to make this whole term equal to 0. From this term, the x value should be 5 in order to make this whole expression 0. And first one and the second one is exactly the same, which we can see right over here. They're congruent, except the a values, our leading coefficient, defines the different types of our graphs. Now, we're just trying to solve the x comma y, which will going to be our vertexes coordinate. So vertexes coordinate. Or let's read this at first. How to solve the vertexes in our binomial form. Vertex is formed by x comma y, where the x is also the input and the y value is always should be the output of the function whenever the function exists. But then we can use our property. There is a property because we don't have to convert binomial form to the vertex form, which we're gonna make us waste a lot of time. And so our property is that our x value, our x coordinates of our vertex is the mean, or we can say is the average of two x intercepts in our functions. That's what our x value will going to be. Now let's actually solve for this. So we know that the average of specific thing is same thing with, so the average of our x-intercepts will going to be adding our two x-intercepts and then divide by 2. Our two x-intercepts will going to be negative 1 plus 5 and divided by 2. This will going to be our x-coordinates of our quadratic function. Negative 1 plus 5 will going to give us positive 4. Divided by 2 will going to give us positive 2. So our positive 2 will going to be our x-coordinate of our vertex. So we can write it down 2 comma y. All you have to solve for it is right now y. But then they gave us something new. They said if you use 18 right now, they said the vertexes between the distance between vertex is 18. We can use our congruent property that if they're congruent, their vertex should always all become same, which means the distance, if we divide the distance, total distance by 2, we're going to be able to solve for the y coordinate of our vertex. And this is going to be way faster way than the first way. But then if you do it, distance will going to be 18, divided by 2 will going to turn into 9. So we can figure out that our y coordinate will turn into 9. Only way that we can apply this was that they told us that these two quadratic functions are congruent. That's why we could apply this to our functions. So we could change it now. So our vertex of this function we're going to be 2, 9. But we are not done yet. We're trying to solve for our a value. At first, let's copy our graph of our quadratic functions back here, because we need to explain something. That if we just find one of our quadratic functions, I will gonna find y is equal to a times x plus 1 times x minus 5. We'll be able to solve for the another one. The reason is because the only thing that is different is the a signs, which makes these quadratic functions flip each other and is symmetrical. So from here, what I'm going to do is we're going to use our property of our input and the output. What I mean by that is we're going to solve it by the elimination equation. So at first, we are going to use our vertex in this case, since we need that input and the output are a function, and our coordinates will going to be the part of our function 2, 9. My strategy will going to be this. When we input some specific value, according to the equation is to generate our specific output of our function. Then we'll be solved for our a value by isolating it in one side. So let's actually do it. When we input x into as a 2 value, as 2, we're going to turn y is equal to a times 2 plus 1 times 2 minus 5. But we need to know one thing here, that our a value right over here, and now a value, our y value here, we're going to be 9. So we'll turn into 9 is equal to 8 times 2 plus 1, and then 2 minus 5. And let's change our when x is equal to 2 into different color, not to be confused. So it is a case where the x is equal to 2. And if you kind of simplify our expression, it will be 9 is equal to 8 times 3 times negative 3. Then we're going to get 9 is equal to negative 9a. So we could see that a value, all you have to do right now is divide both of the terms by negative 9 in order to isolate our a terms. We're going to get, so as in last step, we're going to get a is equal to negative 1. This is we're going to be our a value by solving it through our input and our output. But then in order to solve for this, all we needed here was the coordinate, so that we could actually input and output, use output values. But we're not done yet. We're trying to find our 2 ways of solving with 2 functions. First was when the y is equal to a times x plus 1 and then x minus 5. Our a value is negative 1. Negative 1 times. So there are going to be 2 nominals. X plus 1. And then x minus 5. Second one, we're going to be y. So let's write our second one. Second one, we're going to be a is equal to negative 1, but the negative will turn to positive, so we don't have to write it down. So there will obviously going to be 2 nominals because they're the same. And we're going to have x plus 1 and the x minus 5. And if you see that there is the y value, which we're going to be our output function, we're done solving these questions. So these 2 functions will going to be our final answer of our question.